Okay, so I talked a little bit about zones and how they're guideposts we can use with training, and what we hope they are representing is what's going on physiologically in our body. They aren't like a set heart rate, and as I mentioned, their heart rate is really only kind of a proxy. It's something that we can easily measure, but it isn't really necessarily indicative of what we want to be happening. So when I look to do zoning, hopefully we have a full test and we can use many different metrics. So first and foremost, I use the metabolic cart. I use a PNOE unit. It's going to give us many metrics, but a couple of them that are very useful for finding our zones. Now, besides the PNOE, we can also use a near infrared spectroscopy unit or multiple units. The Moxy monitor is what I use. Basically, it sends an near infrared signal into the muscle, and then sensors pick that back up, and you can tell how much oxygen is saturated in the working muscles and how much blood flow or hemoglobin is also under the sensor. This gives a lot of indication of what's going on locally and can give us a lot of further clues. Also, it's a great device that you can use to monitor intensity just on a day-to-day basis. And we can also bring in lactate testing. So with this, after a certain period of effort, you're going to take a small finger prick of blood, and it's going to analyze how much lactate has accumulated in the blood. And we can cross-check our zones here very, very easily. Okay, so here we're looking at a ramp test done on a treadmill. This first portion is a 3-minute warm-up, and then this larger area is where we're increasing the speed every minute. I'll actually add the speed in here so you can get a visual. All right, constant speed here, and then every minute we're increasing the speed up to failure. And then we capture a 2.5-minute window here where we're looking at recovery. So if we're trying to find zones, there's a handful of metrics we look at, and then we kind of cross-check them. So what I've got up here is this green, this heart rate. We've got the purple is breathing frequency, so how many breaths per minute the individual is taking. This middle line is minute ventilation, so how much oxygen they were consuming per minute. And one way we can find that aerobic threshold is where it's the beginning of the first breathing drive. So let me show you what that means here. So if we watch, it's about very constant amount of oxygen this person is using through these first stages of the test. And then at one point here, we can see that that starts to tail upward a bit. There's definitely a point where it begins to angle up more, and this is that first ventilation threshold. This is why the talk test works so good. This is all conversational effort here. You can talk and you shouldn't even sound like you're exercising. Now, once you cross that threshold and get out of your zone 2 range, now you're starting to breathe a little harder. We can also cross-check this with the breathing frequency. This individual, again, is breathing at almost precisely the same frequency. And lo and behold, right about at this point where the demand becomes greater for more oxygen, we can see that that begins to rise also. So if we say that's right about here, we can go up to the heart rate and see that it's roughly right around 122 to 124 beats per minute. The number on the right-hand side is the value you're looking at. The number on the other side is how many seconds into the test. So that makes it, this shows us here that that is probably that first threshold. Where we find the anaerobic threshold in zone 5 is there's a second breathing drive, which if you look here, it begins to get steeper here, and we can also see that the ventilation rate, breath rate, goes rapidly up through the roof. So we're looking somewhere around here, around 166 beats per minute, it appears in this case. And so we'd be looking at that anaerobic threshold somewhere up in here. So that's how we can use breath to look at the zones. Now, if we pull in another metric here, this is the RAR, which is the respiratory exchange ratio, basically the ratio between carbs and fat. So 0.7 is essentially burning all fat. 1.0 is all carbs, and above that, now you're clearing excess carbon dioxide, either because more is being produced or possibly because of hyperventilation. So this kind of yellow gold line is our line of RER. You can see these easy efforts. It's 0.772, shows mostly fat being used. And the crossover point, where it's half carbs, half fat, is right about the aerobic threshold, and that would be a value of 0.85. So watching it here, we're at 0.84, kind of jumps to 0.86, but right about here, and that lines up almost perfectly with the threshold we identified with the breathing data. And if we go up to the heart rate, looks like that's right around 124 beats per minute then. So that seems to provide more evidence that this is probably right about where this person's aerobic threshold is. Now, where we hit that one, we go above 1, so we find 1.1, 0.01, looks like it's kind of right about in here. And that would show about 141 beats per minute. However, from our breathing data, it looked more like it was actually somewhere out here. Now, if we look here, we've got a 1.24. So that could be potentially a bit of hyperventilation. The breath ranges here don't necessarily indicate that though. And it could, but that number also is subject to what the person has eaten prior to the test. So here we have a little conflicting evidence. So let's see if we can pull in another piece of data. So now I'm going to bring in muscle oxygen saturation in the vastus lateralis, one of the quad muscles. That's this very light green line. This is the saturation. So we started about 56%. You can see it's saturated a little more at onset. Now, at the aerobic threshold, below the aerobic threshold, this should stay relatively plateaued at a high state. So there's no real significant fall. It stays basically plateaued. And then it does start to trend down somewhere in here. That would be where our aerobic threshold is. And if we look once again, this clear beginning to descend happens right about where, with all the other metrics here, we've identified that aerobic threshold is. So this looks pretty firm. So now we've got another point verifying. Now, as we go over the aerobic threshold, what you'll see, or should see, is a gradual decline of muscle oxygen saturation, which is exactly what we're seeing here. But if the effort stayed constant, it would plateau. We can actually see it does indeed plateau right here at around 31, 32%. And then once you cross a certain threshold, you get over that anaerobic threshold. Now you're running on borrowed time and you're going to deplete your reserves rather rapidly. And we see that here, that the SMO2, or oxygen saturation in the muscle, begins to plummet pretty significantly. And that drop is right about where, again, where we identified it with the ventilatory data. So that provides me with pretty good evidence that this is where that anaerobic threshold lies, which is pretty high, pretty near VO2 max, which is a good thing, and not out here where the RER, the carbs to fat ratio, might suggest it is in the case of this test. Now, we could use lactate, which was not done in this case, but we could go in, if we have those values, that would then provide pretty firm evidence of where that might be. Okay, so that's how we find basically some anchor points, right? The aerobic threshold, anaerobic threshold, but then we have to break zones out from there as well. A couple landmarks here. So the first thing we want to do is find our fat max, or adjusted fat max, and that's where the highest amount of fat, which is a dark green line, and the least amount of carbohydrate are being burned. And it looks pretty clearly that's right about here. So if we want to cross-check that with heart rate, it looks like it's somewhere around 82 beats per minute. So that's going to be the end of our zone 1. Zone 1 is going to be below that. And then it's going to be the start of zone 2. And zone 2 takes us to the aerobic threshold, which we already identified was right about here. Somewhere about 124 beats per minute, where the fat and carbs cross over. And also we can see the breathing volume begin to kick upward pretty significantly. So that's our zone 2. Then we'll change our metrics a little bit here. Get rid of the carbs and the fats, and breathing frequency. So we're looking for where that kicked upward a little more steeply, and it appears to kind of go somewhere right about it here, and somewhere about the heart rate about 163 or so beats per minute. That's where we identified the anaerobic threshold. So for zone 3, we're going to go about 10 beats per minute below that. So down to about 153. So now we've got from zone 3 is going to be from the crossover, 124 to about 153 or so. Zone 4 is going to be through there, cross over the anaerobic threshold a bit until we really see the real steep breathing drive, initiating our zone 5. So somewhere around here, let's say somewhere about 166, and then zone 5 is everything above and beyond that. Max heart rate was somewhere around 170-ish on this test. Was a little low on this day, I think. But so that is roughly how we find our zones. And if we had lactate values, we would cross-check those as well and perhaps adjust them a little bit based on that. Okay, so this is a lactate graph just to show you how I would work with this. This is not the same test as I was showing with the PNOE before. I didn't have lactate on that one, but here you can see it's a step test. Started off, well, 1.2 millimoles was this person's resting onset of work, dropped a bit. So the low I saw was 0.8. So 0.5 rise from that is 0.13. Let's see, they hit it here and about 2 stages out. So right about here is where that aerobic, or top of that zone 2 would be. And then as effort rose, eventually they crossed that 4.0 somewhere out here. In this case, just looking roughly maybe around the 155, 153 beats per minute, and then on upward from there. So that would be how you might use lactate to help verify zoning. One last thing for zoning that I don't really have shown here, but between each stage, if I can get RPE, perception of effort, like just in general, legs, assuming it's a leg-based activity, as most are, and breathing. And if the RPEs are not the same, this helps me also parse out what could be limiting factors for that athlete. And that's something we can discuss in a future video. So hope you found these at least a little bit interesting. And if you have any questions, definitely drop them in the comments. Or if you're interested in learning more about testing, reach out.